dishwashing liquid. Now this acts like oil does on a bicycle. How does that act?
It like
greases
grease
it and
it,
makes
yeah.
it run.
What does it prevent from
Rust.
happening?
While making it
The
stop.
chain corroding.
No. It prevents the parts from moving roughly against each other. So it acts as a lubricant and it prevents friction. Because the moment friction happens, if you rub two pieces of metal together or two chemicals together or even your skin together, heat energy is released, which is friction, due to friction. So we don't want heat energy released here due to the friction of the chemicals. Okay, so no, just someone go and get him in, please. Byron, it is not funny. If you want to be a clown, go to clown school, not to Somerville Intermediate. Now come stand here. Right. So, physical or chemical change so far?
Physical.
Just still physical. So in this tube, in this measuring cylinder, we've still got hydrogen peroxide, we've still got food coloring, we've still got dishwashing liquid. Okay. Now we're going to add the...
Does this go boom now?
You may want to move your arm.
chemical. So this is now the potassium iodide.
Put it in there.
Once I've added this, just let's talk about all the different changes that you notice happening.
Holy, that looks like a butterfly.
Okay, what is this? Look over there. What is that?
Smoke, steam.
You don't know if it's steam, you don't know if it's smoke, so it is a gas. So gases are given off. Can you smell the gases given off?
No.
Come closer and you'll be able to smell them.
That's cool.
Okay. Right. What changes did you see happening?
The colour.
There was a colour change. It went from green to yellow and eventually it will
went
go
brown.
to white. Now, it doesn't matter whatever food colouring I added, it would eventually get to the same colour. So the food colouring was to show the colour change in the chemical reaction. What other changes did you see? It turned from a liquid to a
Gas.
gas, and you can still see the
Foam.
gas in the liquid there, which is a foam. So there was a change in texture, change in matter, a change in state.
What happened if you...
What about volume? What's happened to the volume? Increased or decreased?
Increased.
Increased. What's happened to the mass? Increased or decreased? The mass.
Increased.
Decrease?
Why'd you say decreased, Olivia?
I don't know.
What's been given off?
Gas?
Gas. So if gases are given off, have you lost mass? As gases are given off, have you lost chemicals? Have you lost atoms and molecules?
Yes.
Yeah, you have. You've lost all those atoms and molecules in the gas. So what happens with the mass of the chemicals that are left behind? It has
Decrease.
decreased. Okay, so you smelt a gas, you saw a gas, and you can see the little gas bubbles there. And then one thing that you can't see, I'm going to just let you feel. Cup your hand below my hand over there.
Oh, it's hot. Holy moly.
So what is that telling us? What's been given off?
Heat energy.
Heat energy has been given off. Which means, and did the heat energy come from friction? Did the heat energy come from friction?
No.
No, because we stopped the friction due to the dishwashing liquid. So the heat energy actually came from the chemical reaction happening. When heat energy is given off, we call that an exothermic reaction. Heat exiting. Sometimes you have an endothermic reaction. So when we want to bake pikelets, what do we have to do to actually get that baking soda to release its carbon dioxide? so that those platelets can rise.
Mix it with
Heat.
Heat it. Okay, so you put it in a pan. When the other day when we wanted that candle to give off its light and its heat energy, what did we have to do? We had to add a bit of heat energy to get that reaction going. Where did the heat energy come from that you added?
The candle.